Okay guys, sorry about that. I cut off from my last video, so this is part 2. Really sorry, but you're going to have these 2 parts to have to watch. So A said refer to example 1, so I went ahead and I pasted it down here so that we can use it, and it's right here in front of me. It says to identify the ordered pair that names point A, and then identify the quadrant in which it is located. So again, go ahead and number those. 1 is the first one we learned, 2, 3, and 4. If you can always remember 1 is the first one we learned, you'll be good to go. So point A is in quadrant 2. So I'm going to put quadrant 2. And I don't care if you put the Roman numerals 2 or if you write the number 2. Okay, it's not a big deal to me either way. And then it said to identify what the ordered pair is for this point. So on my x, remember we always do our x comma y. On my x, I know I'm going over to -1. And then on my y, I'm going up to 1 1/2. And so my ordered pair is -1 comma 1 1/2, quadrant 2. Now for B, it says identify the point that's located at 1 comma -2, and then identify that quadrant. All right, so over 1 on the x-axis, and then down -2 puts me at E. So I'm at E, and that is in quadrant 4. So point E, quadrant 4 are the answers for B. So it says reflections on the coordinate plane. You can use what you know about number lines and opposites to compare locations on the coordinate plane. Consider the number line and coordinate plane below. The number line shows that -4 and +4 are opposites. Okay, it's like opening a book. Do you guys ever do that thing with the yearbooks where you say, oh, I wonder who you're kissing in the yearbook, and you figure out where your face is, and then you fold it, and it goes to the other person? I don't know. That used to be like a big thing whenever I was a kid, and it would be funny because it was like, you know, not serious, obviously. And so you'd be like, oh, who'd you kiss? Well, this is what would happen if I close the book, and this is the binding right here. These 2 points are kissing, because they're opposites, okay, -4 and +4. So the coordinate plane shows that the points -4, 0 and 4, 0 are in the same distance from the y-axis in opposite directions. So they are reflected across the y-axis. So this is like the binding of our book, okay, or if I put a mirror, if this was a mirror right here, this point and this point would be reflected on each other, okay? And so they're reflected across the y-axis. Now, notice that the y-coordinates did not change and that the x-coordinates are opposite. So they're both 0 for the y-coordinates, and they're both 4s, but one's negative, one positive on the x-axis. Let me show you another one where we're reflecting across the x-axis. So say we've got 2 and -2, okay? This would be 0, 2 and 0, -2. And so in this case, it's reflected across the x-axis. The x values don't change, and we have opposites for the y values, 2 and -2. So that is also called a reflection. So example number 3 says to name the ordered pair that is a reflection of -3, +2 across the x-axis. So this is our binding of our book, and we're trying to figure out what's the other dot that's going to be kissing our -3.2. So it's going to be the same distance away from the binding as this one is. So it would be 2 down, and then it would be 3 over from the y-axis. So -3 and -2 would be the reflection of -3, +2. Remember, one of the numbers always has to stay the same, and then the other one will be opposites. So we've got our -3s that stay the same, and then our 2s and -2 that are opposites. So name the ordered pair that is a reflection of each point across the x-axis. So if you need to use this, you can, just to help give you a visual. You can graph one each of these points on this and see if you can figure out where the reflection is across the x-axis. It's important that you understand it's across the x-axis. Notice that when we reflected across the x-axis here, that our x values stayed the same. Hint, hint. All right, so go ahead and do C, D, and E, and when you come back, we'll go over the answers. All right, so I showed my work here. I've got my grays that represent my 1, -4, so that's down here. I made my binding the green, so I knew that my x-axis is where I'm going to fold my book, right? And so across from that, I'm going to go over 1 up 4 instead of over 1 down 4, and I end up at 1, 4. For my D, I'm going to go to the left -2 and up to 5, and that marks my D to start. And then when I fold my binding across the green line, across my x-axis, I'm going to be going over to left 2, but down 5 this time. And so -2, -5. And then last but not least, my -3, -1, or sorry, my -3, -1 put me right here. And then the reflection would be -3 up 1, and so we've got -3 +1. So think of it like folding a book or putting a mirror up against the line. So Kendall is building a square fence. She places fence posts at the locations indicated on the grid. What is the location of the post that reflects -4, 4 across the y-axis? To reflect across the y-axis, we keep the y-coordinate the same. So just like we did here where all of our x values stayed the same and our y values were opposites, that was when we reflected across the x-axis. The x's stayed the same. Now that we're going across the y-axis, our y's are going to stay the same, and we're going to find the opposite of our x's. So that means it'll be +4, +4. That's the point that's reflected across the grid from -4, 4. Because our, if it's across the y-axis, the y stays the same. Okay, because it's reflecting across the y-axis, and then the x is the opposite. So it was -4, now it's going to be +4. All right, so we're going to look at example F. Kendall also placed a fence post at -4, -4. What is the location of the post that reflects -4, -4 across the y-axis? So again, I can write this, -4, -4. My y is going to stay the same because it's reflected across the y-axis. And then I'm going to do the opposite, and so I get 4, -4 as the answer. Because we're using this as our binding, and our first one was -4, -4 down here. And then to mirror that, we had to come over here, and that's going to be +4, -4. Yay! That's where the book folds and we kiss each other. Well, we don't kiss each other. Okay, that was, if I could rewind, I would. But I don't know how. So let's move on with our lives. All right, guys, that is the end of 5.6, the coordinate plane. I hope you have a great day, and I'll see you in school. Sorry that it's 2 parts.